Hi, in this short little video, we are going to talk about using the counting principles to figure out the size of a sample space when you have compound events. So in other words, this is when we have like a number of options to choose from and you're making more than one option. And like, for example, a basket contains 4 acorn squash, 5 gourds, and 8 pumpkins. How many ways can 2 acorn squash, 1 gourd, and 2 pumpkins be chosen? So we're choosing multiple objects here, and so these are called compound events. Now, to find the number of ways that event A and B can occur, I want you to notice this, A and B, you multiply, you find the number of ways that the first event can occur, and the number of ways the second, and then you multiply that together, multiply those. To find the number of ways that events A or B can occur, you actually, when you see an or, you add those events. So if we are choosing in this first example 2 acorn squash out of 4, well, we're looking at how many groups of 2 you can take out of 4. So that's a combination of 4 choose 2. And then we're going to pick a gourd. Well, you have 5 gourds to choose from, and we're choosing 1. And then we're going to pick 2 pumpkins out of 8. So that would be 8 choose 2. And we want to find the ways that all of them can occur. We have to multiply those together. And so you can type that in your calculator to find your answer there. Now, in the next example, a basket contains 4 acorn squash, 5 gourds, and 8 pumpkins. How many ways can 2 acorn squash, 1 gourd, or 2 pumpkins be chosen? And so here, we're not going to select all of them. We're just either going to get the 2 acorn squash, we're going to get 1 gourd, or we're going to get 2 pumpkins. So we have to look at all the ways that you could choose your acorn squash, so 4, and you're going to choose 2. How could you choose a gourd? If there are 5, you're going to choose 1. And if you're going to choose 2 pumpkins out of 8, 8 choose 2. So it's either going to be this number of ways, this number of ways, or this number of ways. And so you're going to add those together. When it's an or, we add. So let's do some problems. It says a box contains 15 black and 12 red marbles. In how many ways can 13 black and 2 red marbles be chosen? So we're going to choose 13 black out of 15. All right, so out of 15, you're going to choose 13 of them. And tells you to multiply. Out of 12 red, you're going to choose 2. I'll go ahead and work those out real quick like. So 15, we're going to choose 13. And then I'm going to hit times 12, choose 2. And that gives me 6,930 ways. All right, let's do another one. A biology class is preparing for its final exam. From a class of 22 girls and 16 boys, how many groups of 2 girls and 3 boys can be formed? So we're choosing 2 girls from 22. So 22, we're going to choose groups of 2. We're going to look at all the ways you can choose groups of 2 out of 22. And tells you you're going to multiply. We're going to choose 3 boys from 16. So 16, choose 3. So 22, choose 2 times 16, choose 3. That gives you 129,360 different ways that could be formed, that group of 2 girls and 3 boys. So lots of ways. Next, a stockbroker is selling 5 different annuities, 7 different mutual funds, and 9 different stocks. In how many ways can a client choose one of each type of investment for his portfolio? So we're looking at all of the different ways that he could, how many different ways altogether? What is the sample space, or what is the set of all possible outcomes? They're going to choose one of each. So it would be 5, and he's going to choose 1. 7 different mutual funds, and he'll choose 1, and 9 different stocks, and they'll choose 1. So 5, choose 1. I'm just typing this in my calculator here. And you get 315. which when you're just choosing one, it's the same as if you went 5 times 7 times 9. Use the fundamental counting principle because you have 5 options, 7 options, and 9 options. All right, now let's work with cards. So this is a deck of cards. You'll want to make sure you know how a deck of cards is set up. We have 52 cards altogether. Half are black, half are red. We have 4 suits, clubs, spades, hearts, and diamonds. And we have 12 face cards, Jack, Queen, King in every suit. Okay, so find the number of possible combinations of 5 cards that contain 5 face cards. So we are going to have 5 cards in our hand, and they're all face cards. But there are how many face cards altogether? Well, there are 12. So we want to look at all the ways that you could have groups of 5 out of 12. So that would be 12. Choose 5, and that would give you your answer there if you punch that in your calculator. The next one says find the number of possible combinations of 5 cards that contain 4 kings and 1 other. Okay, so we have a combination going on here, and we have kings, 4 kings, and we have 1 other card. So we're going to have 5 in our hand. So if we're looking at that hand of 5 cards, there are going to be 4 kings. So how many ways can you get 4 kings? Well, there are 4 kings. So we have 4 kings, and we're going to choose 4. So really, that's just going to be one way. You're going to have all 4 kings. So 4, choose 4. If you put that in your calculator, that gives you 1, okay? And means times you want 1 other card. Well, how many cards are not kings in a deck? Well, 48 of them aren't. So we're going to, out of 48, we're going to choose 1. So that would be 48. So there would be 48 different ways that you could have 5 cards in your hand that has 4 kings and 1 other card. All right, next, find the number of possible combinations of 5 cards that contain 1 ace and 4 cards that are not aces. So we want to find all the ways you can have 1 ace. Well, there are 4 aces to choose from, and we are going to choose 1 of them. And tells you to multiply. Well, you want 4 cards that are not aces. So you have to say, okay, how many cards are not aces? Well, there are 48 that are not aces, and we're going to choose 4 of those. So we have to look at all the ways out of 48 cards that we could get groups of 4. And then you would multiply those together. Next, find the number of possible combinations of 5-card hands that contain 5 hearts or 5 diamonds. So we want all the ways that you could get 5 hearts. So first of all, you have to think about, okay, how many hearts are there? There are 13 altogether, and you are going to look at all the groups of 5. So 13, and we're going to choose 5. Or means you're going to add 5 diamonds. There are 13 diamonds, and you want to choose all the groups of 5. We want to look at how many groups of 5 there are to figure out all of the possibilities that you have. Okay, here's another one. Find the number of possible combinations. It contains 3 queens and 2 other cards. Okay, so how many queens are there altogether? There are 4, and you want to choose 3. So we have to look at all the ways that you could choose 3 if there are 4 possibilities. All right, and means times, and you want 2 other cards. So how many cards are not queens? Well, there are 48, and you're going to choose 2. So that would, if you type that in your calculator, that would give you your total sample space for your total possible outcomes. All right, that's that for this lesson. Let me know if you have questions. Thanks for watching.